Okay, this is a review on my power supply for my ion lifter by request. So this way, if anyone else wants to build one, then they can use these designs. First off, the batteries that I use are the Venom 11.1 volt 3 cell 5000 milliamp batteries. I have two of these, so this way I have two of the same batteries. My next battery is a PolyQuest. This one is a 14.8 volt battery. I've had it for a while, so the 14.8 is already done wore off, but I still know it's 14.8 volts on this battery. Now, everyone I know uses DC flyback transformers. I've tried it. It's never worked for me. I don't know. So I purchased AC flybacks. The first one I bought was this one here, a Thor Darson 81. I can't find the specification sheet on it, but this was rated at about 18,000 volts. So I was actually able to find and purchase two of them on eBay, $10 a piece. That's all they cost. I was also able to purchase this one. This one was rated about 15,000 volts, but it doesn't give the performance that I really want. And this one also. They're okay, but not as good as these two. These two are really the best ones I've discovered. Okay. Voltage multipliers need AC voltage input. So I've built voltage multipliers. This is a capacitor rated at 20,000 kilovolts. I don't know if it's picking it up. Let me see. There we go. 20,000 kilovolts with the diodes. This is a positive voltage multiplier because the two inputs down here, one is going to be ground. The gray in the front represents positive, black in the back is negative. So the output up top is gray. That means the high voltage coming out is positive. Now, here is another one. This one is rated at 15,000 volts. This one too is this one is a negative voltage multiplier, because now at the input wire, the gray is at the front, the black is at the back. So the high voltage out would make this a negative voltage multiplier. Still runs the same as a positive. This one is the same as this one. I just made this one more evenly spaced, but the one inside the box is a positive voltage multiplier. This one is a negative. If you were to connect these two together to a common flyback, sharing the inputs, you would have even more high voltage output from the positive and the negative. This one, I was able to get 225,000 volts out of it. Because I measured it, it was 9 inches. So that's 25,000 volts per inch. That only happened to me maybe twice. On average, I'll get out about 150,000. But then I guess that depends on temperature, humidity, and moisture also, you know. Now, As for the flybacks, this one is a Royer circuit. It's kind of like a ZVS. You have capacitors to oscillate, you have an inductor, and you have two MOSFETs and resistors for the base. And you plug it in, you get a nice high voltage AC arc. But for some odd reason, this doesn't have enough power to lift my lifters. My original design, where I just, in my other video you can see on my lifter, I just had the coil and the feedback, which went to the base of a tip 102 Darlington transistor. That's what I used. So in a earlier video, I had made my own ZVS driver, and this is it right here. I'm using the 260N MOSFETs. You got the fast switching diodes, 10K resistors, diodes on the back. You can see base resistors to the MOSFETs. And let's see, we got an inductor here. And I did different tests with the capacitors to find out which one actually resonates the best for me. This one is a 2UF capacitor. I know you can't see it. Let me see if I can zoom in on it. It's not too clear though. And I even had another one that I tried. This one was a 3UF capacitor. I tried this one, but this one seems to work the best for me. I had a ZVS circuit I bought off of Amazon, and it ran good until the ion lifter wire touched it and blew it out, blew out the MOSFET. And since I had already previously built this one, I said, you know, let me try with this one. This one actually produces better results than the one that I bought off of Amazon, because this was the inductor that came off of that ZVS. So now with this flyback, I used a much heavier gauge wire. The electrical engineer told me you gotta use heavy gauge wire because if you're gonna be pulling a lot of amps, then the wires can't produce enough current flow to go through it. So he picked out these wires for me. This is actually a base connection I had for my pulse width modulation that got burnt out. So I just quickly joined these wires together just to have it there. And I got a smaller inductor out of a power supply unit from a computer. You know, or you take apart any electronics that don't work anymore, you find plenty of spare parts in there. You know, and I just have two alligator clips, and basically I'll just plug these in, and I don't have an on-off switch because, you know, with the amperage going through this, I can actually burn the points. So right now, for the time being, I just may touch a wire. But what I want to do is not use pulse width modulation, because what I discovered is when I was running my lifter, if I was pulsing it fast enough at the right rate, then I could actually get to kind of hover in one spot. So, and since ZVS drivers don't like pulse width modulation because it needs a minimum of 12 volts, when this is fully charged, it is 12 volts. So I'm not going to combine two batteries and have 24 volts. That's more mass, more weight. I don't want to deal with that. So I thought about it and I said, okay, I'm pulsing it manually at a slow rate. So why can't I just use a 555 timer, but not in pulse width modulation, but as a frequency generator, which could activate a MOSFET which would trigger the current going in to the ZVS. And if it's a low frequency, but what's the duty cycle? How long it stays on? Actually control the height of that. So I said, okay, that's not a bad idea. And another thing is the electrical engineer, he drew up some schematics for me to follow with a 555 timer. A lot of people say when they run their inventions, they wonder why the 555 timers blows out. That's because there's an electrostatic field in the area that also can blow out the 555. And also if you're running it on the same power supply. So right here, he's going to be using a 9-volt battery. He has a pull-down resistor. And he said to use an optocoupler. So there's no physical connection between the timer and the power unit, because it already has a transistor built inside. So I can actually have this transistor power another MOSFET, and I'll actually be able to control the frequency. So if you like what you hear, or you want more further information about how I did this, just let me know, and I'll see if I can load up another video for you. And I'm still working on the ion lifter. I was able to get it to produce more thrust now. Still running on the same battery. I didn't modify anything. When I'm running the system, I usually use this flyback, and I will use this voltage multiplier. Now all I gotta do is just fill this with some mineral oil to keep the from breakdown occurring. But yeah, if you like what you see and what you hear, if you want more information, just let me know, and I'll get back to you as soon as I can. Okay, bye.